first thing we're going to do is we're going to list a compass that has directional bearing on it, okay? We have north, we have east, we have south, we have west. And we're going to take care of that in a little bit. But I'm also going to put another compass here. And this compass is going to be a numerical compass. 0 degrees goes at the top, 90 degrees goes to the right, 180 degrees goes at the bottom, 270 degrees goes to the left, and then 360 degrees goes back to the top, which is the same as 0. Are we okay with those two? I do understand. I didn't connect with this right away until somebody told me, but they said, well, that's kind of confusing, Mr. Gens, because the way we set it up before is that 0 was over here, and we went counterclockwise. Now we're putting 0 up here, and we're going clockwise. So I get it. I get it. So I don't want a direction. I want a number. Give me a number. If I were to walk towards Bryant, what bearing would I take? 0 degrees. Everybody see that? I'd be going north. Approximate. What bearing would I take if I were to walk to Maggie?
60.
Sure, 60 degrees, 45. It's somewhere between 0 and 90, right? Somewhere between 0 and 90. 90 would be over this way. 0 is that way, so it's got to be between 0 and 90, right? Approximate the bearing for me to walk, for me to tie.
135.
Close. 135 is actually going to be back over here.
No, it'd be like
From you to me is 135. From me to you,
like 290.
sure, 300, something like that. It's got to be between 270 and 360, right? I'd be walking in that northwest direction, which is between 270 and 360. Now, I change. I plant myself in a different spot. Now, if I were to walk from me to tie, what bearing would I take? 180. I'd be walking south, wouldn't I? So it depends on where you're sitting as you think about that bearing in that location. So you're going to see triangles that have all sorts of angles, and we want to start to figure out direction so we can take the law of sines and cosines and apply them to real world situations. This went very, very well during third hour. You are the most intelligent class, right? So this should be no problem for you. We have 110 degrees here. B is 28 degrees, and C is 42 degrees. And it gives me a hint here in saying that C is directly to the west of A. I'm going to give both a directional bearing and I'm going to give a numerical bearing. I'm going to do both of them, and we'll show you the difference between those two in just a second. This is a 2-day lesson. We do 2 examples today. We do 1 tomorrow, and you have the rest of the hour to work, which you should be able to get caught up on a lot of it during that time. So I'm going to start by planting myself at C. I'm going to put myself right here. And to show that I'm standing at C, I draw a little compass there. What is the direction of travel to get from C to A?
90.
90. Give me as a direction, not as a number.
East.
East. That is straight east. So C to A is east. So that's what I write for the directional bearing. Now, the direction to get from C to B is not south, east, north, or west. It's kind of a combination. How would you describe the direction to get from C to B?
Northeast.
Northeast. So what I write is north and east. And what we do is we always turn from north or we always turn from south. We never turn from east and west. It's always from north or south. So from the north line, how many degrees do you turn towards the east? It's not 42. 48. How'd you get that? Yeah, everybody agree that 48 and 42 make 90, so I had to turn 42 from 0, and I get 48 degrees from there. So I get, this is north, 48 degrees east. Great. Notice how we fixed the ones that are sitting at C. I'm going to now put myself up at B. and I'd like to describe the direction of travel to get from B to A. What's the direction of travel to get from B to A?
Southwest.
So B to A is southwest. So from south, how many degrees do I turn towards the west? So 62, because you say 28 from 90, but we're missing that one and that one, aren't we? It's kind of hard to see, isn't it? And so after teaching this for a number of years, I think this is the best way to go about it. We're just going to finish off kind of a triangle grid here. And this will help us to be able to calculate those missing pieces. I'm going to make a 90-degree angle there. I'm going to make a 90-degree angle with my grid there. Now this is a little bit of geometry review. You know that there's 180 degrees in the triangle. If there's 180 degrees, this is 48, that's 90. What would this be right here?
42.
This is 42 degrees.
Wait, can you say that one?
Oh, it's just.
Yes. So 180 minus 90 is 90.
Yeah.
Minus 48 is 42.
What's that?
So
What's that
all
theorem?
three of those angles add up. What's that?
Isn't there a theorem that's like?
Yes, I've tried to introduce that before, and I would say about half the class kind of loses me on it. But without a doubt, these are called alternate interior angles. If you notice alternate interior angles, you can use that. You see it coming up over and over in the lesson, but I don't really mention it too much. These three angles have to add up to 90. So I have 70, so it would be 20 more. So this angle is 20. And then this bottom one here will be 70 degrees. So I have all the parts of my triangles filled out. Now I should be able to make quick work of this. Again, we're going from B to A. It's southwest. How many degrees do we turn to the west?
20.
20 degrees. I'm going from B to C. Still southwest. How many degrees do I turn to the west from south? I got to turn from south.
48.
Yeah, you turn 20 and 28 to get 48. Great. I've got my locations at B. I got my locations at C. Now it's time to plant myself at A. I'm going to head on over here to A. We'll do the easy one first. A to C. What's the direction?
West.
Straight west. Now we're going to go A to B. General direction?
Northeast.
Northeast. From north, how many degrees did you turn to the east? 20 degrees. Because the 70 and the 20 add to 90. 20 degrees.
So why don't we say like? Why wouldn't we just say west 270? Like, do you not have
Yeah,
to?
can you do that?
Yeah, so we're going to do that right now, okay? All right, so now let's go to your point, Brian, there, okay? We'll kind of start at the bottom, we'll work our way up, okay? C to A has a numerical bearing. So I don't want to just describe it as east, but rather the number is going to be
90.
90. If I'm at C or A and I'm going to C, the number is
270.
270. If I'm going from C to B, notice this is 0, and from 0 I turn 48 degrees to the right. So that's going to bring me to 48. Now I'm going to go from B to C. So I'm going to turn 48 degrees past 180. What's 48 degrees past 180? 228. We're going to go from B to A. From B to A, I turn 20 degrees past 180. What's 20 past 180? 200. And finally, A to B, that's 0 degrees. I turn 20 degrees past 0. That brings me to 20 degrees. So you should be able to handle both sets of bearings. They come up in different situations. I'd say what's most commonly expressed in our assignments and whatnot is going to be the directional. But I want to show you a way to kind of check your result. It's two kind of neat ways. Notice A to B and B to A. Those are direct opposites, aren't they? Well, look, one's northeast, one's southwest, and they both have 20. Here's southwest, northeast, both have 48. But here's another thing. If I'm walking in this direction and I arrive to my spot and I turn and do a 180, we call that when you turn around, right? 180. Look at these. 20 and 200 differ by 180. 48 and 228 by 180, and 90 and 270 by 180. Good way to check your answers to see if you think you got them right. Okay? So that's our quest for today. We'll do one more example here. B is directly north of A. B is directly north of A. It says that angle A is 68 degrees. Angle B is 50 degrees. And angle C is 62 degrees. Whoop. I'm going to go ahead and I'm going to put down my 3 compass marks right away, and then I'm going to go ahead and kind of make the rest of my grid, because I know I'm going to need some help figuring that out. As you make that grid, go ahead and finish off the angles in there. See if you can figure out what they are, what goes where. It's a good geometry review as we prepare for your ACT coming up in not too long, juniors. I'll fill them in so you can check. Everybody good with that? Any question on that? Okay, let's start at position A. Describe A to B. North? A to C, I would describe as north. Whoops, sorry about that. A to C, I would describe as northwest. From north, how many degrees did we turn to the west? 68.
Wait, what one do we base it off of? North and south?
Always off of north and south. Okay.
So that's like what our first letter would be?
Yes,
North or
always
south?
north or south.
Okay, I was really confused.
Yep, good question. So now I'm at B. I'm going to go to A. What's my direction?
South.
South. Now I'm going to go from B to C. I describe the direction as southwest. So Lily, from south, how many degrees did you turn towards the west? 50. Try the last two on your own. I got C to B was north 50 degrees east, and C to A was south 68 degrees east. You good with that? Okay, let's do the numerical bearing then. A to B. Straight north is
360.
0 or 360. Could do either one. Typically 0 is what's listed. B to A. 180. B to C. So some people like to think about this multiple ways. You could either go 40 degrees back of 270, or you could go 50 degrees past 180. Either way, it brings you to 230. C to B, you go 50 degrees past 0. Now you get 50 degrees. A to C, you can think of 68 degrees back of 360, or you could do 22 past 270. Either way, you get a 292. And finally, C to A, 68 degrees back of 180. That would be 112 degrees. I checked to make sure that they differ by 180 and that these seem opposite, and in fact they are. All right? So what's different about the example that we'll look at tomorrow is that none of these are perfectly north, south, east, or west of each other. And so that changes it just a little bit. But you guys will be fine with it. I want you to look at your assignment so you can see what we want you to do.
How are these alphabet? Are these two? Oh, defer.
Okay, there's a total of 9 problems. The first 6 are what match with what we did today. The first 6. I would encourage you to come to class tomorrow with at least the first 3 done. Or if you can't get them done because you're confused, make sure that you are at a point tomorrow like, hey, Mr. Gens, I tried some of these. I'm really confused. I could use some help. See what I'm saying? We're going to do one example tomorrow in class, and after we do that one example, you are then going to then have the rest of the time to work. So, like I said, we build in some more time here. Rest of the hour is yours. Good job.